In this video, we are going to discuss example 18, the integration of cos raised to n odd power, which is 5. The integration can be proceed by first splitting the odd power of cos into the product of an even power, which is one order less than the original odd power, and a linear cos x term. We then make use of the identity that relates the square of sine and the square of x, which is sine square x plus cos square x equals to 1. This identity will allow us to express the even power term in terms of sine square, whereas the cos x term can be related to sine through a very simple differential relationship. Namely, the differential of sine gives you cos x dx. To take into account of this dx term, I will multiply dx and I'll do the same thing on the left hand side. By doing so, I will be able to express cos power 4x as cos square x and square again. Cos power 4x could be then expressed as 1 minus sine square x and square again. These represent cos power 4. The product of cos x dx is defined to be differential of sine x. I can now define u as sine x so that this can be expressed as d of u equals to cos x dx. I'll be able to express this line of equation in terms of u, which is 1 minus u squared per square and du. We look at the original integration. Cos power 5 is expressed in terms of u. The integrations in terms of x involve cos power 5 of x. After the substitution as shown, translate the integration with respect to x into the integration with respect to u. The integrand now exists in the form of a polynomial in u, which is easy to integrate. We open up the bracket of the integrand. This will give me 1 plus u power 4 minus 2u power 2. Integrating the polynomial of u is easy. It gives me these expressions. Next, I'll substitute u equals to sine x back to this line of equations. U is just sine x. The second term would be 1/5 of sine power 5x. Third term would be 2/3 of sine power cube x plus n constant. So that is the solution to the integration of cos power 5. As a conclusion, we have discussed how to perform integration for cos raised to n odd power. The trick is to break the odd power cos into the product of an even power and a linear power of cos. Then we use the identity that relates square of sine and square of x to express the even power cos into the form of sine, whereas the product of cos x dx is expressed as a differential of sine. Then in terms of u equals to sine x, the integrand together with the dx then is expressed in terms of u, so that the integration with respect to x is now translated into integration with respect to u. Performing the integrations of u is easy. After we have integrated the integrand in terms of u, we then substitute the expression of u equals to sine x to arrive at the final solution for the integral of cos power 5 x dx.